Okay, our first question is to, given OH minus concentration, find the H3O plus concentration, the POH, and the pH. So our first step is we can set up this to find our H3O plus. We can do 10 to the negative 14 divided by 8.33 times 10 to the negative 6 equals our H3O plus. So let's get our calculator. And it is 10 to the negative 14 divided by 8.33 times 10 to the negative 6. And that, 10 to the negative 14 divided by 8.33 times 10 to the negative 6. And that becomes 1.2 times 10 to the negative 9. And how we can check this is if our exponents equal negative 15. So negative 9 plus negative 6 is negative 15, which is close to negative 14. So that's how we can check. So our H3O plus concentration equals 1.2 times 10 to the negative 9 molar. Now, what we can do is find our pH. So our pH is, POH, so negative log of OH minus concentration of 8.33 times 10 to the negative 6. And once again, you just plug that in the calculator, which becomes negative log of 8.33 times 10 to the negative 6. What do we get? 5, which is pretty accurate because it should be a little less than this exponent. So we get 5.08, we can say. Now, we can also use the acid-base square pretty much again, and we can do 14 minus 5.08, which is the POH, 5.08, to find our pH, which we can just 14 minus 5.08, we get, 14 minus 5.08, we get 8.92. So our POH equals 5.08 and our pH equals 8.92. And here are our answers. Now our next one is a really simple one. So we have 2.71 times 10 to the negative 3 molar of, what is this? It's a strong acid, HBr. And the question is, what is its pH? So this is really, really simple. We can use our acid-base thing, our acid-base square, and we pretty much just do negative log of what? Our concentration. 2.71 times 10 to the negative 3. And once again, we should know that since our exponent is negative 3, our negative log should come out to 1 close to around 3 or less than 3. So let's do that. Negative log 2.71 times 10 to the negative 3. So we should come out with a pH close to 2 to 3, around 2 to 3. And we get exactly 2.57. 2.57 is the pH. So the pH equals 2.57. Boom. Okay, our next one is 3.22 times 10 to the negative 4 molar of CaOH2. And our question is, what is the concentration of the OH minus? So pretty much we have to make sure that we know that there's the 2 here. So with this 2, that means we have to multiply this, which is really simple. 2 times 3.22 times 10 to the negative 4, which comes out to be 6.44 times 10 to the negative 4 molar of our OH minus concentration. So really simple. Okay, so the next one is a reaction, and we have to, our goal is to find the pH. So first, we should notice that we're not given a Ka or Kb, and the reason for that is, remember, strong acid. So this is a strong acid, which means it dissolves completely into the next. So pretty much there is no need for a Ka or Kb. Okay, once we have that figured out, we can pretty much know, since this is 0, our Q will be 0. So we will going to the product side. So our change, remember, there's no X or anything. It's completely, so it's minus 5.26 times 10 to the negative 4. This is dash, this is dash. And this becomes plus 5.26 times 10 to the negative 4. And same here, plus 5.26 times 10 to the negative 4. And our change is, this just becomes 0. This becomes 5.26 times 10 to the negative 4. Same here. And once that is done, we can pretty much solve for our pH, because to find the pH, it's negative log of this equilibrium concentration. So pH equals negative log of 5.26 times 10 to the negative 4. And we should note that, and we should note that what we should probably get is in between 3 and 4, because I remember our exponent is what kind of determines that. So we can go negative log 5.26 times 10 to the negative 4. And what do we get around 3 and 4? Boom, 3.27, sorry, 3.28. And that is our, pretty much, that's the pH. That's how to solve that. Okay, our last one is HF plus H2O goes to H3O plus F minus. And our Ka is 6.8 times 10 to the negative 4. And our final goal is to find the pH. So we should notice that HF is not a strong acid, which therefore makes it a weak acid. And we can also tell by seeing that there is a Ka here. So what we have to fill in is the initial concentration. So we can assume 0 and we can assume 0. Now, since that's 0, our Q has to equal 0. So we're going to the product side. So we would minus X from here, then we would plus X, and we would plus X. Now our our equilibrium would be 1.88 minus X. This would just be X, and this would be X. So now we can set up our equation. So our Ka, 6.8 times 10 to the negative 4 equals products over reactants. So X times X over 1.88 minus X. And once we have that equation, we can solve for X. So we go to math, numeric solver, and we plug in 6.8 times 10 to the negative 4. And here we go. X over 1.88. Let's do actually 1.88 minus X. And we can 0 equals alpha solve. Boom. Our X equals 0.035. So now once we have that, that is our X. And that is so since we're finding pH, we have to find that H3O plus. And we found our equilibrium concentration, which equals 0.035, since it's just X. And with that, we can use the negative log times 0.035 to find our pH. And basically, with that, negative log of 0.035, that comes out to be 1.5. 1.5. So that is our pH, and that's it.